Hey, welcome to the Explainer. So what happens when the fundamental rules of science just break? Today we're going to dive into Thomas Kuhn's pretty revolutionary ideas about what a scientific crisis really looks like. It's this moment of just profound uncertainty, but it's also packed with incredible opportunity. So we're going to explore that whole turbulent, messy, and honestly really creative process that happens when the scientific certainties we all trust just start to crumble. All right, so here's the plan. We're going to follow the whole journey, right from that first little crack in a theory, all the way through the chaos of a scientific breakdown, and then see what it looks like at the dawn of a whole new worldview. Let's get into it. Okay, so first up, we're starting in a place Kuhn calls normal science. Now, this is just the day-to-day work, right? It's where one single dominant theory, he calls it a paradigm, is basically the unquestioned map of reality. It sets all the rules for all the research. You can think of it like you're confidently filling in a map where all the big coastlines are already drawn. But then, every once in a while, you find a piece of the puzzle that just won't fit, no matter how you turn it. And that is what Kuhn calls an anomaly. So, okay, what happens when these anomalies don't just go away? When they persist? Does just one strange result bring the whole thing crashing down? Well, the answer is, surprisingly, no, not at all. Yeah, Kuhn really emphasizes this point. Science is full of these little mismatches between theory and fact. I mean, scientists run into data that doesn't quite fit all the time, but they almost never panic. Instead, these anomalies, they often just get set aside, with this faith that, hey, future work will figure it out. And this is just a brilliant illustration of that. For 60 years, think about that. 60 years, a central prediction of Newton's theory was known to be wildly inaccurate, and the best minds in Europe couldn't fix it. And yet, nobody, not one person, was calling to reject Newtonian physics. Their faith in the paradigm was just unshakable. And guess what? In 1750, they were proven right. It was a simple calculation error, not a problem with the theory itself. Okay, so if one big anomaly isn't enough, what does it take? What finally turns a nagging, persistent problem into a full-blown crisis that shakes the very foundations of a science? Let's take a look at that tipping point. Well, according to Kuhn, it's rarely just one thing. It's usually a combination of factors. Maybe the anomaly strikes right at the very heart of the paradigm. Or maybe it just lingers for decades, slowly eating away at everyone's confidence. Or maybe a whole bunch of serious anomalies start to pile up, making the entire system just feel unstable. And that's when the crisis really begins. The anomaly stops being a side project and becomes the central focus, drawing in all the top minds in the field. Everything else just gets put aside. And this marks the big transition from normal science to what Kuhn calls extraordinary science. And during a crisis like this, the old rules just get thrown out the window. That trusted map everyone was using? Gone. And this unleashes a period of just profound uncertainty, a lot of philosophical debate, and some really wild, untethered innovation. I mean, listen to this from Copernicus. He basically saw the astronomy of his day, the Ptolemaic system, as a kind of Frankenstein's monster of a theory. It was so patched together with little fixes for all the anomalies that it didn't make any coherent sense anymore. So he wasn't just tweaking the calculations, he was challenging the monster itself. And what's so powerful about this quote from Einstein is the emotion. He just perfectly captures that feeling of professional vertigo you get in a scientific crisis. That feeling of literally losing your entire intellectual footing. Right, so this is not some cold, detached process at all. We're talking about the greatest minds feeling deep, real frustration when their guiding theory fails them. I mean, look at Wolfgang Pauli here, one of the pioneers of quantum mechanics. He's expressing this almost desperate wish to just escape the chaos entirely. So this intense, rule-breaking period of science, it can't last forever. The anxiety, the ambiguity, it's just too much. According to Kuhn, the crisis has to end, and it always does in one of three ways. Okay, so outcome number one. Turns out normal science was capable of handling the problem all along. The old paradigm holds and faith is restored. Whew! Outcome number two, the problem is just deemed unsolvable for now. It gets shelved for a future generation with better tools. Or, outcome number three,
the most dramatic of all, a brand new candidate for a paradigm emerges and a battle for its acceptance begins. Now, when that new paradigm finally takes hold, it's so much more than just a new theory or a better equation. It is a fundamental, ground-up change in how scientists actually see and interact with reality itself.
See, a new paradigm doesn't just answer the old questions in a different way. A lot of the time, it just dismisses those old questions as totally irrelevant. It starts posing entirely new ones, and in doing so, it redefines the entire field from scratch.
Kuhn uses this fantastic analogy. He compares it to a Gestalt switch. You know that classic optical illusion, the one that can be a duck or a rabbit. You can switch your perception back and forth between the two, but you can never, ever see both at the same time. Kuhn says that's what a paradigm shift feels like.
So after that perceptual switch happens, scientists aren't just seeing things a little differently. They are, in a very real sense, working in a completely different world. The exact same data, the exact same experiments, they now mean something entirely new. Why? Because the very framework for understanding it all has changed. So what Kuhn's work really shows us is that science doesn't just progress through a steady, neat accumulation of facts. It moves forward through these revolutionary, world-altering crises. It's a messy process, it's a human process, and ultimately it's an incredibly powerful one. And all this, it leaves us with a really tantalizing question, doesn't it? What is the biggest anomaly in science today that could be pointing to the next great paradigm shift?